All right, so we're talking about interval notation. If you saw something like this, that in a daycare, they went from age 5 to age 9, and then they had an empty circle here and an empty circle here. Do you get that would mean that they could take from 5 to 9-year-olds, but they can't take 5 and they can't take 9? Get that? How would I change this so they could take 9? Fill in the circle, and then this in interval notation would be 5 comma 9, and what would I have around the 5? Parentheses, and the 9? Bracket. All right, that's interval notation. Let's move on from interval notation to the next important thing you learned. If they give you 2 points, 2 comma 7, 9 comma negative 11, you should be able to write me the equation for that with that big long y minus y sub 1. All right, I'm going to say the first part. I'm going to hand it off to somebody else who'll say the next part. Who's going to hand it off to somebody else who'll say the next part. So it starts with y minus. What's next? There you go, y sub 1, and then point at somebody else to have to keep going. Y minus y sub 1 equals, good, and then m, good, hand it off to the next person. Nail somebody with it. X, keep going, yes. This is the general form of the equation. X minus, getting a little help over the shoulder there. Yes, x sub 1. Okay, good. So it's really important you have this memorized. Y minus y sub 1 equals m times x minus x sub 1. So this was the other half of that worksheet, was about that. And if you are given, oh, by the way, if you wanted a reason why do you care, 14 of the ACT questions are on coordinate geometry, which is like this. This is coordinate geometry. I'm not saying there's 14 questions exactly like this. This is one of those kind. This will be on the SAT or the ACT test. I pretty much can guarantee it. All right, because there's 14 out of 60. That's a big percentage of the test is on this kind of stuff. All right, so what's the slope of these guys? That minus that. Negative 11 minus 7 over that minus that. 9 minus 2 is 7. So that'd be negative 18 sevenths. It's okay if it's ugly. I'm not going to have to really multiply that number in later. I just need to plug in some more stuff. X minus y minus, and then I put a point here, and the x, I could pick either one. I'm going to pick that one because there's no negatives. So the x part is 2, and it goes here, and the y part is 7, and it goes there. Raise your hand if you understood what I just did. Good. Then we're on to the next day. What did you learn yesterday? It's called linear regression. I will try to help you understand it from the beginning, but you will need a graphing calculator. I'm going to pause for a moment while you get your graphing calculators out. All right, some general background information. Why do we do this? Because linear regression helps you to draw a line for data. And when could you use that in the real world? I'll give you an example. Let's say that they have a missing person report. In fact, they probably got, let's say, 30 active in Minnesota. People that have been gone missing and never have been found. And all of a sudden, some hiker that's hiking around Lake Calhoun, sees like this hand sticking up out of the leaves. And they realize that, oh my gosh, it's a body. And in fact, all they have is the hand. Okay? Well, they have charts that tell them, do you get that a really tall person would have a really big hand? A really small person would have a really small hand. Well, they have actual charts that can tell them, based on the measurements of this hand, we can tell this was a 7-foot tall person, or at least close to a 7-foot tall person. You see how that narrows down your list of people that are missing? All of a sudden, it can't be this, it's got to be that guy. There's only one 7-foot tall missing guy, so it must be him. So you can just have the measurements from one bone, and you can tell so much. You can tell sometimes if it's male or female, even without DNA. And you can tell how tall the person is. So let's even simplify it more. Instead of just hands compared to how tall you are, do you get that you could measure a pinky? And if a person has a really tiny pinky, they're probably a really small person. And if they had a really huge pinky, they're probably a really big person, right? So you could just have the pinky bone of a person and be able to tell how tall they were. All right, so let's have some numbers like for pinkies, and this is height, and this is pinky length. Do you get if I was way over here, the person was really short but had a long pinky? That's not going to happen. Do you get if I was up here, the person's really tall and has a long pinky? Does that make sense? Yes. And you get if I was over here, that the person was short and had a short pinky? All right, so do you get that the data is not going to be in a perfect straight line because we're not like manufactured on a manufacturing line. We are a little more random than that, okay? So the data is going to be kind of like all over the place, but it's generally going to move like that, okay? You can take that data and you can get an equation for it. Once you got the equation for it, you can use it to predict, I've got this pinky that's this long. How tall is the person? You need the equation for that. All right, so if I got a bunch of data and I put it into my calculator, you're going to do what's called a linear regression on it. I want you to put this simplest of all data into your calculator. If I had graphed this and it went up perfect straight line, it would be 1, 1, 2, 2, 3, 3, and 4, 4. Do you get how those would be super simple points? Let's put those into your calculator right now. So I'm going to go to my stat button. First of all, if you didn't learn nothing else, I hope you learned it was under stat. Underneath stat, it's under edit. I've already got them in there. Would you please take some time right this second and put 1, 2, 3, and 4 in both L1 and L2. How do you clear? You have stuff in your list? I would just hit delete on each individual item and it'll go pretty fast. The delete button, just delete each item. There is a way to delete the entire list, but I don't want you to delete the L1 list entirely, which can sometimes happen, and then all you have is an L2 and an L3, which gets confusing. If you need to completely clear your calculator so that it's like your calculator has never been used, like factory new, and that sometimes brings people's lists back in order, you can do this, but it'll wipe out any games you have stored on it. But if you don't have any, don't worry about it. Second plus 7, 1, 2. Those 5 buttons in a row totally clear your calculator. They're kind of handy to know if you're in the middle of your SAT test or your ACT test, and all of a sudden your calculator freaks out, you don't know how to fix it, you can't just bring it to the proctor and say, please fix this. They won't. If you do second plus 7, 1, 2, it fixes it like it's brand new. Unless the batteries are actually dead, in which case you're really good advice is to change your batteries before you start that big test. Okay, back to this. I hope you've entered 1, 1, 2, 2, 3, 3, and 4, 4. Now, how do I do a regression for it? You go to Stat, and anybody remember from yesterday? Calculate, over to Calculate, and it's the 4th one down. Yep, Lin Reg. Now, no, just before if you've already gone, just look at mine. Do you get that there's also Quad Reg? What are these things? That's a linear regression. The next one's a quadratic regression. That means if your data is shaped like a parabola, you use that. That's what we're going to do next month. And the month after that, we'll start throwing in cubic reg. That's a cubic regression. And that means your data kind of looks like a cubic graph, which means your data starts out like that and then goes up like that. All right, so anyway, we're eventually going to do lots of different regressions. The research shows that if you tell kids where you're headed, they're more likely to understand it more when they get there. So that's why I'm telling you this. All we're doing today is Lin Reg, but I don't just want you to think it's Lin Reg. It's a linear regression versus a quadratic, which is like a curved regression. All right, so number 4, and once I'm there, it's waiting for info. Some of yours have a different operating system, and yours actually says a list of stuff it wants to know. You can just hit enter. As long as you entered them on list 1 and list 2, you're golden. You don't have to type in a bunch of junk there. You can just hit enter. Now, what is this? This is an equation. Y equals ax plus b. I really wish that they just used mx plus b, because that's what you're used to, right? You're used to showing mx, and the m is the slope. But it's the same exact thing. They're telling you the slope is 1 and the y-intercept is 0. And if you think about it, back at our graph, do you get how our slope was 1 and our y-intercept was 0? So it actually fits. So your equation they give you fits your data. If I did one for this height and pinky length one, it would go like this. It would be a line, a straight line that runs through my data the best. It's also called a line of best fit. All right. I think I am recording. Let me check. I'll check the recording. Yep, it's running there. Okay, so back to, what do I do from here? I've got an equation, y equals ax plus b, and they're telling me a is 1 and b is 0. So if I actually put that all down, y equals a, what did it say a was again? 1x plus, what did it say b was again? That's the equation then. Y equals 1x plus 0, also known as y equals 1x or y equals x. And isn't that the equation for this line that goes like that? Yes, it is. All right, so what if you get a more complicated one? You put in more complicated information, of course you get a more complicated equation. It'll say y equals ax plus b, and it'll say a is like 5,212, and b is like negative 215. So you just stick the a in here, and stick the b in there, and you got your equation. This happens to be the number of llamas in Peru at any given time. Okay? And so I've got llamas and time are my x and my y. So I'm going to write this out a little more clear. So y equals 5212x minus 215. So would you see in what year they had 1 million llamas in Peru? Yep. Of course it can change. I mean, I could go over there with a, with a explosive device and get rid of a whole bunch of llamas. Or I could bring llamas. That's a much happier thought. I could bring lots of llamas. Yes, of course it could change. But same with like the pinky thing. Couldn't you stretch your hand and make yourself have this mutant long hand? You could force a change. But given data, you can predict. So where now, I know some of you are like, okay, so I got this million, where do I put it? Is million a time, or is million a number of llamas? A number of llamas. Which one is a time? X or Y? X is a time. Therefore, you don't put it there. This is where time goes. Why does time go in X? Because time is independent. Time always has to go on the bottom. So time has to be your X. All right, so this is time and this is llamas. That's where the understanding part comes in. You have to look at your problem that you're given, and it's usually about time and money, or time and population. And they'll tell you a time, or they'll tell you a population. It's usually population. Happen to be doing llamas because they're more interesting than people. And so I'm going to put my million right here. And now, if there's 1 million llamas, it was in 18 something. I can't remember what it was. Somebody figured it out yet? I could be remembering it wrong. Okay, so I have where would I enter this? You are not entering this. You were given this. This is the part where the calculator would have said this. And now you have to use your brain to make the equation and stick the 1 million number wherever it makes sense. And 1 million is not a time. That wouldn't make sense. 1 million is the number of llamas. Goes there. How do I solve it? Add 215 to both sides, then divide by 5212. Did somebody already do that? What did you get? No? What did you get? 192? Same with you? All right, excellent. 192. I was thinking it was like 1920 something, but I guess it was in the year 192. All right, so bottom line is we solved it. We got x equals 192. I don't want you permanently messed up, so I'll tell you I just completely made all that up. But you can make equations like that for real with real numbers and llamas, etc. Okay, so let's say I give you one more, and here's the equation. Y equals 16x plus 38. And let's say that's the number of, I don't know, geckos that are at the zoo. Now, if I gave you a time, where would you put it? X. So let's say I said on day 5, I want to know how many geckos are at the zoo. You'd go, okay, 5. I got to either put it here or here, and a 5 is a time. Day 5, I'm going to put it there. So I go y equals 16 times 5 plus 38. That'll tell me how many geckos are at the zoo. Yet if I did tell you geckos, if I said, when are there going to be 90 geckos, you could put that where? Why? So I put 90 here, and then I could solve it for x. All right, so all we are right now is caught up with, that's what you were supposed to learn yesterday. Now, if you're worried about today's homework, don't, because I'm only going to give you today's homework, I'll tell you how to do it one last time. I did tell you before. It's about graphing both sides of an equation by just graph the left side, graph the right side, see where they cross. We've already done that before, and you're only going to have to do the odds on that. And then the homework is just to finish up whatever you were supposed to learn for the last couple days over the weekend, looking at the keys, now that you've been retaught how to do it, and then come back tomorrow with the odds from this new worksheet, Monday, sorry, the odds from this new worksheet plus the other worksheets you were already assigned. Just make now you have more time to do them, okay? And then another little detail that was hanging out there is I did assign this 2-minute teacher deal with due today, but I'm not collecting it today because we have too much to do because I've been gone for the last 2 days. Okay? Well, we are going to collect this eventually, get it done. Okay, both sides. All right, that was ACT prep stuff. So now, where are we? We have one last thing, and that's the actual worksheet. I'd rather do one with you than give you another general example problem. So here comes the worksheet, and remember, we're only doing odds. All right, let's do the first one together. All right, it asks for any x and y intercepts that are shown in the graph. Well, number one is a graph that looks like this. It's kind of a U shape. And it looks to me like it's got one y-intercept right here. And it's got a couple x-intercepts, which would be right here and right here. It tells you that the graph is -3 to 6. That just means that way to the left over here is -3 and way to the right over here is +6. And that the y coordinates are from -3 to 8. So they're not saying the answers by giving you those. They're just saying how it's numbered. So basically when they ask for the x and y intercepts, there's the y-intercept, there's the two x-intercepts. That's all it is to it. Let's look at number 3. Does that have a y-intercept? Does it touch the y-axis? Yes. That's the y-intercept, 0. How about the x-intercepts? It's got 3 of them. You can do that yourself. Let's move on to number 5. Number 5 says x squared plus x minus 1 equals 0. And they want you to graph it and then make a sketch of it and then tell what the answer is. All right. Well, I don't even know what this, I'm pretty confident it's a parabola. I generally kind of know it's going to be a U shape, but I don't know what it looks like till I graph it. So let's graph it. X squared plus x minus 1. So you put it into your calculator. X squared, I had a minus 1 in there. I'll do x squared plus x minus 1. And I hit graph. Now, I taught you about how to do this a different way where you graph both sides and you see where they cross. That's my favorite way to do it. But I do need you to understand a different way that some of the other teachers use, and that's called finding the zeros. The bad part is it'll only work if your equation says equals 0. My way, it'll work if the other right side is like a 10 or a 50 or whatever you want. This doesn't have to be a 0 over here. My way, if you graph both sides and see where they cross, will always work. But it is true, a lot of times they're equal to 0. So there's this thing called finding the zeros. Look, it's under second. Calculate the zeros, number 2. All right, now, do you see how it's asking you a question? It's blinking at the bottom. What's it asking you? The left, what does it say? Left found. All right, that means go to the left side of where you're talking about. These are the zeros, right there and right there. You know, those are the spots where it's going to touch. So I need to be to the left. First of all, I have to pick one of them. I'm going to pick that one. And now it wants me to be the left side of it. Pick a boundary on the left side. So I arrow my little, like whatever you call that thing, a little spider, to the left side of it. And when I hit enter, watch for the little thing that comes up on the screen. Do you see that little caret that just showed up on the screen there? It's saying from here to, and then it'll put another one on the other side. Now I'm going to arrow over to the right boundary. Get just to the right of that little spot that I'm concerned about. There, I'm just to the right of it. I know I'm under it, but I'm also to the right of it. Then I hit enter. And then it says guess. Now I'm going to go over right on top of it, and I'm guessing that I'm about right there. And I hit enter, and the exact answer is negative 1.618. That happens to be the golden ratio, which is kind of an interesting number. All right. How many of you actually got negative 1.618 to come up on your calculator? All right. For others that got lost in there, that's not many of you. I'm a little scared for you. I'm going to try this one more time. Everybody, get back to the y equals screen. Everybody. Just stop talking. Everybody, get back to the y equals screen. I'm going to try to fix that for you right now. So you listen. Look and see if your plots are on. If anybody has a plot that's darkened in, you won't be able to graph it. Next thing, look and make sure you use a minus sign for your 1 and not a negative sign. If you use the negative sign, it won't work. It won't graph it. All right? Okay, now that you've all checked for that, now hit graph. And are any of your graphs not showing up? They just won't graph it. I didn't ask about that. Did it graph or not? All right. So then I'm going to go. There. Anybody else? Will it graph or not? Okay. Yeah, yours is really whacked. I'm going to do the second plus 712. You have any games you're going to lose? Okay. It's all better now. That's permanent, goofed up. Somebody like leaned on it or something. Let's kind of wipe it. There you go. Should work like a charm now. Anybody else who's not? It's not working for them. Yeah, yours is whacked. Actually wrong with the calculator, so this one's batteries are dead. All right, charts. All right. Is there anybody who still can't get the equation or the thing to graph? All right, once you get the graph, it's working or not? Okay, good. To get it to do the next step, you got to go second calculate the zeros. It's number 2 on the list. Everybody do that with me right now, and you'll follow. If you follow each step with me, you'll be all right. 0, enter. Notice its question at the bottom. What does it say? Left bound. We got to get to the left side of it. Now, there's 2 points that are important here. This one and that one. I'm going to do the right-hand side one. I'm going to focus on this one on the right. Right where it touches the x-intercept there. Okay, so I want to get to the left of that. So I'm going to arrow over until my little spider is just to the left of the important spot I'm talking. Now I know it's under, I'm using left and right arrows to do that. Okay, and now I know I'm underneath it, but I am to the left of it. All right, and I hit enter. And now it's right boundary. I'm going to go just to the right of it now. Just over, so I'll be above it, but I'm also to the right of it. Enter. And the last thing is guess. That means get really close to the spot you want. I'm going to arrow to guess it's about right there. Hit enter. And it says 0.618. And that's the right answer. Raise your hand if you got that one to work. All right, that's like 4/5 of it. That's way better. Okay, now if you still have trouble with that, come and get some help after class. The other thing I want to show you is, remember, I told you that if you had like this, you can just graph both sides and see where they cross. But this one you wouldn't be able to use zeros because why? Because it's not set equal to 0. But this one I would graph this side, graph that side, and I'd see where they cross. All right. Now I'm not positive that this one, let me think if it'll work or not. Yes, it'll work. All right, I would like everybody to graph this one. Put in that on your first equation, x squared plus 3x, and that on your second equation, 17. If you're not fast enough, I will be doing it here, but I want you to at least pay attention to me. It was x squared plus 3x here. 3x, and then I'm going to get rid of that last little character. And the other one is 17. And the first thing that happens is kids freak out because when they hit graph, they can't sometimes see the whole thing. And if you can't, you can always zoom out or zoom in or adjust your window until you can see it. Do you see that line that's going across at 17? I don't. Then I'm going to zoom out. Zoom out. If I zoom out, I'll probably be able to see it better. And I have to hit enter. And there it is. Now I can see where they cross. Now, to see where the two things cross, I use intersect. I go second, calculate the intersect point. Let me get this little thing out of here. The intersect is number 5. There we go. And it asks first curve. Am I on the first line that you want to see about? And yes, you are. And now it moves up to the other line and says, am I on the second curve? And yes, you are. And then I arrow over to where I want to say, I think they cross right about there. And I think it's about 3.4. And the answer is 2.887. The first question is, am I on the first line? The second question is, am I on the second line? The third question is, get really close and guess. And then it tells you the answer. Raise your hand if you got 2.88 on that one also. Okay, good. So, graph both sides. See where they cross with intersect. Or, if the equation's set equal to 0, then you can do the whole graph and find the zeros. I personally like the intersect one, because it'll always work. Always, always. Graph this, graph that, see where they intersect. All right, covered a lot of stuff. Sorry you didn't have too much time to ask me lots of questions, but at least you now know what you're supposed to do. Tonight you are going to go fix the mistakes you made on your test over the weekend. You're also going to do the odds on this worksheet, only the odds. Then you're going to check this and anything else you had trouble with over the weekend so that on Monday you're all ready to grade some stuff. We need to put a bunch of stuff in the grade book on Monday. We've got about 30 seconds left if you want to catch me right before the end of the class with a question.